Hi friends, welcome back. So we are still doing the Fourier transform only. So let's see the next property which is very important for Fourier transform, which is Parseval's theorem. Parseval's theorem. I already told you we have discussed this Parseval's theorem in Fourier series also. There we have talking about what is the power of x of t, how we can try to find out power of the signal from the Cn, that is nothing but Fourier series coefficient. So here also Parseval's theorem is talking about energy here. So if I know how to calculate the energy of a signal x of t, which is integral minus infinity to infinity mod x of t square dt. So this is the way we can calculate the energy of the signal x of t. Next, but what is the what is the Parseval's theorem is saying that instead of x of t, if I know x of omega, still I can calculate what is the energy. Then what is the formula we have to use? Is 1 by 2 pi integral minus infinity to infinity mod x of omega square d omega. Next, the same formula can be written as integral minus infinity to infinity mod x of f whole square df. This is also one way to say. So these are the formulas you have to remember in the Parseval's theorem. So to calculate energy, if I know x of t, this is the formula. If I know x of omega, this is the formula. If I know x of f, this is the formula we have to use. And here one important thing is mod x of f square is nothing but energy spectral density. So it is called as energy spectral density. So if you know energy spectral density, if I integrate with respect to f, that means area under energy spectral density is nothing but the energy. So I hope you understood. So mod x of f whole square is called as energy spectral density. Energy spectral density. ESD. ESD. Sometimes even this one mod x of omega whole square, that is also called as energy spectral density. But now if I know energy spectral density, if I integrate it, so energy can be calculated by the integration of energy spectral density with respect to f, or I can integrate energy spectral density with respect to d omega, but we have to say 1 by 2 pi. So these are the formulas. That means area under energy spectral density with respect to f, that is nothing but energy. With respect to omega, but we are having 1 by 2 pi factor extra. So these are the way we can calculate the energy. Clear? Take it. Example. Find energy of x of t is equal to sin at by pi t. Sin at by pi t. So if I try to calculate energy directly, energy of x of t by using x of t, so that is nothing but integral minus infinity to infinity mod sin at by pi t whole square dt. So to calculate this integral, it is difficult. So it is difficult to calculate. Difficult to calculate. Then what we can do? We can do one thing. We can calculate energy spectral density. How we can calculate energy spectral density? Let's see. So for this x of t, what is x of omega? So we know x of omega is nothing but a rectangular pulse which is existing between minus a and plus a, whose gain is equal to 1. So this is what x of omega. Now, what is energy spectral density? Which is mod x of omega whole square. So if I calculate modulus for this one, so modulus for 1 is nothing but 1 only. If I take square, still it is going to be 1 only. So this is the energy spectral density between minus a and plus a, whose value is equal to 1. Then what is the energy formula? Energy of x of t is equal to 1 by 2 pi integral minus infinity to infinity mod x of omega whole square d omega. So this is what energy spectral density. So what is the area under this function? Which is nothing but 2a into 1, that is nothing but 2a by 2 pi. So which is nothing but a by pi joules. So this is what the energy we can calculate. So by applying Parseval's theorem, we can calculate energy of the signal in a very easy manner compared to the difficult time integration. Clear? Take it. Okay. Next, convolution in time domain. Convolution in time domain. What is this property? Suppose if a signal x of t convolution with h of t, then in the frequency domain, if x of t having x of omega, h of t having h of omega, then this is nothing but x of omega multiplied with h of omega. So in simple we can say convolution in time domain leads to multiplication in the frequency domain. So that's what it is actually. Suppose if I know a system with the transfer function h of s, then if I know x of s, then output is nothing but x of s into h of s. That's what it is actually. So instead of s, we are having omega here, frequency response. Okay. So let's say impulse response. H of t is given. For this system, if I give x of t is the input, then output y of t is nothing but x of t convolution with h of t. Suppose if the system is shown with a frequency response, that is h of omega. For h of t, this is nothing but Fourier transform. Then x of omega is the Fourier transform. Then what is y of omega? Which is nothing but x of omega multiplied with h of omega. So remember, these systems are LTI systems. Then only we can apply the convolution. I hope you understood. So this is what we are saying in convolution in time domain. Okay, take it. So for this, if I take one example, let's say e power minus at u of t convolution with e power minus at u of t. What is the result of these two convolutions? So if these two signals are get convoluted, then we have to get t e power minus at u of t. I want to get this t e power minus at from the Fourier transform. Let's say how we can do this. For this one, Fourier transform is nothing but 1 by a plus j omega multiplied with 1 by a plus j omega. So finally this is equal to 1 by a plus j omega whole square. 1 by a plus j omega whole square. So for 1 by a plus j omega whole square, what is the inverse Fourier transform? That is nothing but t e power minus at u of t. T e power minus at u of t. We have seen that for t e power minus at u of t, what is the Fourier transform? 1 by a plus j omega whole square. So that means inverse Fourier transform is also same. So I hope you understood. This is what it is. Clear? Take it. Let's take an example. And remember, it is like a standard. Okay. So it is a standard question. Standard. The question is, sin alpha t by pi t convolution with sin beta t by pi t is equal to sin gamma t by pi t. Gamma t by pi t. Where gamma is? So options. Gamma is equal to alpha plus beta. Option B. Gamma is equal to alpha multiplied with beta. Option C. Gamma is equal to minimum of alpha comma beta. Gamma is equal to maximum of alpha comma beta. Alpha comma beta. So which option is going to be correct? Okay. So one very important thing just now we have seen, convolution in time domain leads to multiplication in the frequency domain. So by using that property, I can calculate what is the gamma value. So let's see what it is going to be. So first let's say sin alpha t by beta, pi t. It is having Fourier transform, which is nothing but a rectangular pulse. So actually it is a low pass filter. It is a low pass filter. Zero minus alpha plus alpha 1. Next, we are having sin beta t by pi t. With respect to omega. Let's say I intentionally taken this beta value is more than alpha value, minus beta 1. We know that if convolution in time domain, leads to multiplication in the frequency domain, then what is the resultant of these two if I multiply them? So 1 multiplied with 1, it is going to be 1 only. But is it existing from minus alpha to plus alpha or minus beta to plus beta? So if I multiply these two things, whichever is a small, that's what we have to take. That means if I take a curve, the resultant curve, which is equal to, so in this case it is existing between minus alpha and plus alpha, because after that it is going to be 0. So I can say whichever is the minimum, that's what we have to take. So it is going to exist between, let's say, minus gamma and plus gamma. What is this gamma value? Which is nothing but minimum of alpha comma beta, whichever is the minimum, that's what. So if it is a rectangular pulse for this one, what is the time domain actually? So again, sine gamma t by pi t, gamma t by pi t. So this is what it is equal to. So if I convolute sine alpha t by pi t, sine beta t by pi t, so we are going to get sine gamma t by pi t. Then what is the gamma value? Which is nothing but minimum of alpha and beta. So option C is correct. Suppose if it is asked like this, let's say sampling, let's say 5t convolution with a sampling 3t. So before going to that, let's see. Sine 5t by pi t convolution with sine 3t by pi t. What we are going to get, which is same as sine 3t by pi t. So this is the standard model. So whichever is the smaller one, that's what we have to consider. Now, if the question is sampling 5t convolution with a sampling 3t, then what is the answer? You cannot say sampling 3t, that is a wrong answer. Sampling 3t is a wrong answer. Then what is the correct answer? Then let's say this can be rewritten as sine 5t by 5t convolution with a sine 3t by 3t. Still it is not in the standard form. So if I multiply with pi square by 15, if I take 5 out, 3 out, then sine 5t by pi t convolution with a sine 3t by pi t. This is in the standard form. So for this one, we know the answer is sine 3t by pi t. So for this, so pi square by 15 sine 3t by pi t. So pi get cancelled, pi by, let's say 5, then sine 3t by 3t. So this is the pi by 5 sampling 3t. So this is the answer. So it is not sampling 3t, actually it is pi by 5 sampling 3t. That is the answer. Take. In a similar manner, suppose if it is asked sinc 5t convolution with sinc 3t, then what we can do? So this can be written as sine 5 pi t by 5 pi t convolution with sine 3 pi t by 3 pi t. So this 5 is extra, so write it down, 1 by 15 sine 5 pi t by pi t convolution with sine 3 pi t by pi t. And for this we are having, which is the smaller one, sine 3 pi t. So this is what we are going to get finally, 1 by 15 sine 3 pi t by pi t. So I want in the form of sinc. So then what we can do? This 15 can be written as 3 into 5. So bring this 3 here. So 1 by 5 sine 3 pi t by 3 pi t. So this is going to be sinc. So 1 by 5 sinc 3 pi t. That is what the answer is. time integration property. Time integration property. What is this property saying? Listen. If a signal x of t having Fourier transform x of omega, then integral minus infinity to t x of tau d tau. This is called as running integral. For this running integral, what is the Fourier transform? X of omega by j omega plus pi capital X of 0 delta omega. How did we got this? Actually, integral minus infinity to t x of tau d tau can be written as x of t convolution with u of t. In the basics we have discussed this. If any signal is convoluted with a step signal, that is nothing but the integration of the given signal. Now, for this one, what is the Fourier transform? We know from the convolution property in the frequency domain that is going to be multiplication, then x of omega multiplied with 1 by j omega plus pi delta omega. That is what the Fourier transform for u of t. Now, if I multiply this, x of omega by j omega plus pi x of omega delta omega. Next, any signal multiplied with delta omega, then omega has to be replaced with 0. Then this is going to be x of omega by j omega plus pi x of 0 delta omega. So this is what it is going to be. Clear? Take it first. For a function g of t, it is given that integral minus infinity to infinity g of t e power minus j omega t dt is equal to omega e power minus 2 omega square. If y of t is equal to integral minus infinity to t g of tau d tau, then integral minus infinity to infinity y of t dt is equal to dash. So this is the question. Take it. So let's see one by one. So forget about everything. They want to calculate this integral. So let's say this, from the central ordinate theorem I can say y of 0, that means if I know for y of t y of omega is there, capital Y of omega, that is frequency domain, Fourier transform. In that we have to calculate y of 0. That means y of omega at omega is equal to 0. That's what the value we have to calculate. Okay. Now let's see, coming to these integrals, what they have given. They have given for g of t, this integral value is equal to this one. So if you observe carefully this integral, this is nothing but Fourier transform of g of t. This is nothing but Fourier transform integral. So integral minus infinity to infinity g of t e power minus j omega t dt. It is nothing but the Fourier transform. So I can simply say this is nothing but g of omega. G of omega. And they have given what they have given? Y of t is equal to integral minus infinity to t g of tau d tau. So from this I can say, that implies what is y of omega? Y of omega is nothing but from the integration property g of omega by j omega plus pi g of 0 delta omega. So if I substitute g of omega here, so this is nothing but omega e power minus 2 omega square by j omega plus pi. What is g of 0? So if I place omega is equal to 0, this value will become 0. So pi into 0 into delta of omega. So this value will become 0. So finally this is minus j e power minus 2 omega square. This is y of omega. So what is this integral? Minus infinity to infinity y of t dt, which is y of 0. What is y of 0? Minus j e power 0, that is minus j. So minus j is the answer. Clear? Take it. Take it down. Next question. To an LTI system having impulse response h of t is equal to sin 4t by pi t. If input is x of t is equal to cos 2t plus sin 6t. Find y of t. Find y of t. Find output. Okay. So many people think that we have to do the convolution because x of t is given, h of t is given, but it is not required. Why? Because h of t is nothing but sin 4t by pi t. H of t is sin 4t by pi t. What is it actually? It is a ideal low pass filter. Ideal low pass filter. And with cutoff frequency 4 radians per second and pass band gain is equal to 1. So if I draw h of omega, so how it look like with respect to omega? Zero, minus 4, plus 4, 1. So this is what the ideal low pass filter. Ideal low pass filter. For this one, what is the input we have given? The input is x of t. X of t is equal to cos 2t plus sine 60. Sine 60. So we are having two frequencies here. One is 2 radians per second, another one is 6 radians per second. So if I pass the signal through this low pass filter, then this signal will pass and this signal won't pass, because it is having a frequency which is 6 radians per second out of the pass band. So then it is going to be attenuated. This is going to be pass, and with a gain is equal to 1. So if I multiply with 1, it won't make any difference. So what is y of t? We are going to get output, which is cos 2t. Cos 2t. So simply think like a low pass filter. If I am passing any signal through a low pass filter, then which frequencies comes out of the filter, which frequency is getting attenuated. So sine 60 is out of the pass band, cos 2t is within the pass band. Clear? Take it.